Hi students, today we'll discuss one more topic in our electrostatics, that is electric potential and potential energy, right, associated with the charges, right, and we'll discuss very detailedly, so how to calculate the potential difference for continuous charge distribution, right, these all the things, different models, and equipotential surfaces and conservative forces, therefore how to solve the problems of equipotential surfaces, all this one we'll discuss in this chapter. So before this I already discussed electric field and Gauss law and Coulomb force. All these concepts we already discussed in the three videos are there. So if you did not watch, please watch it, so then you can understand very clearly about this electric potential and potential energy and equipotential surfaces and problems. Okay, so let us start our video. Okay, now, so first of all let us discuss what is mean by this electric potential. Electric potential, right? So suppose there is one charge is there, this is one charge. What this charge it will do now? This charge, so it will create certain amount of electric field. We already discussed in our electric field lesson now, right, in an electric field video. So this charge is creating the electric field here now. Therefore in this one what is present here now? So here field lines are spreaded in the spherical onto this one now. In this one now electric field lines are present now. We already discussed about this detailedly onto about the electric field lines now. Then suppose now what we are going to do now? We are going to take one charge. So one small test charge we are going to take it, positive test charge now, which is outside this field treated to be at infinity. So therefore here there is no any influence on this charge, no. So this is free now at infinity. Therefore the potential it will be equal to 0. Therefore the potential of the charge due to this charge at infinity is treated to be 0. Now what I will do now? Therefore I will bring this charge. So till here, before entering the field, the work done is 0, because there is no other extra field is there, we need not to do any work onto this one, till from here to here there is no work is done onto this one, work done is 0. But you try to observe, once it is started entering into this field, this charge what it will do now? It will exert the force. In which direction it is going to exert the force now? Because of due to positive charge, this also positive charge, repulsion force it will be acting onto this. But I want to make this charge to move toward this side, right? I want to keep it here somewhere here now. What I should do? I should exert the force. In which direction I should exert the force now? So I should exert the force in this direction now. I should exert the force. In which direction is object is moving now? In this direction only the object is moving. I am exerting the force, and in this direction only the direction is there, force is also in the same direction, no. So therefore work is said to be done is positive. Work done by the external force is positive. Clear? So therefore to bring this charge, therefore here certain amount of work I should do it. Therefore the amount of work done to bring a charge from infinity to certain point is called like a electric potential, right? We can calculate the potential here now. What is the potential here now? So electric potential can be defined as, so V is equals to work done per unit test charge. Yes or no? So this is a simple formula, potential at any one particular point here now. Therefore here what you can write now at this point now, therefore at point A, so work done to bring from infinity to certain point A. Clear? Therefore we will write down clearly here now. So potential at this point is what? So work done to bring this charge from infinity to certain point A. So the amount of work done per unit test charge now, we will call it as like a potential at that point. Clear? So now we will see some basic information now. So work done per unit charge is how much now? Work done, what is the SI unit now? SI unit. What is the SI unit here? So work done is nothing but a joule per, therefore here charge coulomb. So joule per coulomb, if 1 joule of work is said to be done on 1 volt, 1 coulomb, therefore it is said to be like a 1 volt. 1 volt. Clear? So therefore what will be the dimensional formula here now? Dimensional formula, so therefore work done is nothing but M1 L2 T minus 2. So charge is nothing but what? Therefore AT. So you can take it here, no. So therefore M1 L2 T minus 3 A minus 1. This is your dimensional formula, right? So, of this potential now. Clear? So, one very important point is what? It is a vector or scalar, therefore, it is a scalar quantity. It is a scalar. Work done is a scalar. So, charge is also scalar. Therefore, so potential it is said to be like a scalar. One very important point you need to note down, no? When you are calculating the force, that is Coulomb's force, no? Next, when you are calculating the electric field, what you have to do, no? There you have to consider at that point, no? Consider 1 plus 1 Coulomb in which direction the forces are acting. So, vectorially you have to add it and simplify it, no? But in calculating the potential and potential energy, so therefore, you need not to take therefore, here directions and all this are no. If it is a positive charge is there, you can take positive. If it is negative charge is there, negative only you have to use it. But in forces and field, no, even positive charge is there, negative charge is there, it doesn't matter, no. We already only depends upon the force direction onto this one. So that I already discussed in that electric field concepts, no. So go through it thoroughly so that you can understand very clearly, no. Now, so this is a potential, it is a scalar. If it is positive is there, positive, negative is there, negative. Therefore, so here positive charge if you bring it, no, therefore work done is said to be positive. So potential will be positive. So therefore, if it is a positive charge is there, so potential will be higher. If it is negative charge is there, negative charge means this one, no. Negative charge is creating there, therefore potential was negative. Clear? So repulsion force, potential was positive. So attraction force, potential was negative. Right? That is, you need to be very clearly. So higher potential will be there. So this is the potential at this point A. Now suppose if you take it as at this point, no, suppose I am taking at this point here B. So at point B. So here to bring this charge, no, from infinity to this point. Therefore, so work done from infinity to B by Q is nothing but a potential at B. Clear? Therefore, so here, so can you tell me where the potential will be more, no? Therefore, we are bringing very near to this charge, no? Potential at B is greater compared to the potential at A. Therefore, in between this one now, there is a potential difference will be there now. So, what will be the potential difference now? Potential difference B to A. So, therefore, potential at B minus potential at A. So, that is nothing but a work done to bring from A to B by the charge, no? This is your potential difference. Clear? So, be careful on this one, no? Therefore, these type of questions, no? And one more important formula we can rewrite it as, no? Charge, I mean work done to bring this one, now it will be equal to Q into potential at that point, right? So, that is from infinity to certain point, no? Therefore, so if we want to move from this point to this point, no? So, work done to move from B to A, that is A to B. So, therefore, here A to B, so therefore, Q into potential difference, whatever the potential difference here we calculated, so that we have to use it, right. So, one interesting question here, no. So, even therefore, work done can be measured in terms of like a, so here a charge into potential difference, no. Therefore, the unit of energy, therefore, the unit of energy can also be, work done is nothing but a joule. Therefore, 1 joule also can be written as, so there is nothing but a joule, so can be written as, so for an electron, therefore, E electron volt is a one more unit of our energy, electron volt. You know that 1 electron volt is equals to 1.6 into 10 to the power of minus 19 joules. So, this is your in terms of electron volt, that means we are bringing the electron, no? Clear? So, across the 1 volt potential difference. Clear? In this way, we can calculate the work done in terms of like a electron volt. Clear? Now, we will see. Here, we already discussed this electric potential here, no? So, we will calculate what is the potential created by this one, no? So, what is the potential which is created by the point charge, no? So, here, so potential due to point charge, right. So, therefore, so work potential it will be equal to integral, so work done, therefore, dW. So, therefore, here work done by the charge, no, therefore, Here work done is nothing but what F dot dr divided by the charge onto this one. Clear? So therefore here, so work done, therefore in opposing to this one, no? So therefore here you can rewrite it as it will be like a minus onto this one. No? So V is equals to, so F by Q is nothing but a minus integral E dot dr. This is very important formula. We will study very detailedly about this formula now. Right now we will discuss only because of due to the point charge. No? So V is equals to minus integral. Electric field due to this one is how much now? We know it, no? K capital Q by r square into dr. Clear? So therefore here kq taken common, therefore r to the power of minus 2 means what? Integration, no? R to the power of minus 2 plus 1 by minus 2 plus 1. So this is minus, no? Therefore minus 1 plus 1, no? Therefore kq by r. This is your potential due to the one single point charge. That is nothing but a V is equals to 1 by 4 pi epsilon naught into q by r. You know that electric field is inversely proportional to the square of the distance, no? And potential due to the point charge is inversely proportional to the distance onto this. Clear? So it is inversely proportional to the distance. And also this potential does not depend upon the test charge which are bringing, no? This potential is created by the source charge. That means here, so this source charge is there, no? Therefore this charge is only creating this potential, no? So we are calculating this potential at this point because of due to this charge. This charge only is creating the field, no? So here we are calculating the potential, no? So it does not show effect on which charge you are bringing onto this one, no? Clear? So potential due to one point charge can be written as like a V is equals to 1 by 4 pi epsilon naught into q by r. So what is the work done, no? Work done you can rewrite it as, so work done will depend onto this one, no? Q into potential here, no? Clear? So this potential here, no? You can rewrite it as, right? So we will do some numericals onto this one, no? Very detailedly. So a lot of numericals, no? It does not have any direction onto this one, no? Is a scalar, no? If it is positive charge is there, plus potential will be there. If it is negative charge is there, no? Negative potential only will be created onto this. Clear? You understand, no? So now we will see some more problems, no? Related to this. First of all, let us discuss potential energy. Clear? Right. So now we will discuss again, that is potential energy, electrostatic potential energy, that is U. Clear? So electrostatic potential energy, see here. Suppose here there is nothing is there, there is no other field is there, no? If there is no field here, so therefore here some two charges are there. Suppose here q1 charge is there, no? Therefore q2 charge is there. So to arrange this one, to arrange these two charges, no? So we have to do certain amount of work. So whatever the work is done to arrange these charges, like a like this arrangement is there, no? Therefore the amount of work is done is stored in the form of like a potential energy. How you can believe that there is a energy stored, no? Suppose if you take these two charges, keep it here, no? Because of due to the repulsion, if you leave it, they will be moving with a certain amount of speed. That means it is gaining kinetic energy. So that means how the kinetic energy has come, no? Before that, therefore there is a certain amount of energy was stored. How that energy is stored? Because of due to the configuration, the arrangement, right? So to arrange this one now, how much amount of work is done, that energy is nothing but a, so that work done is stored in the form of a potential energy. Let us see some simple question, simple concept, no? To arrange this one now, we have to bring one charge q1 from infinity, so we have to place it at point q. So therefore at one point, no, q1 we are going to keep it. Here there is no other extra field is there, no? Therefore work done it will be equal to 0. Suppose if any extra field is there, no? Therefore we have to do certain amount of work to bring the charge now. Clear? Another charge is there now, place q2, we have to bring from infinity to certain point here. So to bring this one now, this charge is creating some field here, no? So therefore it is exerting some force onto this. So like potential we just now discussed, no? It is creating field. So here potential will be created by due to this one, no? It is going to exert, no? Therefore we have to do certain amount of work to bring this charge now. So therefore q2, so these are arranged, no? What is the work done here now? Work done is nothing but a q1 is a potential which is created. So therefore which one we are bringing, no? Q2 we are bringing, therefore potential due to 1. Clear? So therefore, whatever the work done, no, so W is equals to Q2 into V1. No. Yes, sir? So whatever this work done, no, it is stored in the form of like a potential energy. Here W is equals to Q2 into V1. So W is equals to Q2. So the potential due to this one now is created at this point. See, potential is created this one now. This charge now is creating the potential here now. Clear? So what is this potential due to this one now? Just now we derived now previously. So what is the potential due to this Q1 now? Therefore 1 by 4 pi epsilon naught into Q1 by R, the distance between this one now. So this whatever the work done is stored in the form of like a potential energy. Therefore 1 by 4 pi epsilon naught into Q1 Q2 by R. This is your potential energy due to these 2 point charges. Yes or no? So here this we are calculating the potential energy assuming that there is no other extra field is there. Suppose if any extra field is there onto this or no, therefore we have to do the work against that field plus we have need to arrange like this onto this. Clear? So if you have some numericals onto this or no, so that you will get clarity, but this point you should remember now. So this is your potential energy formula. So U is equals to 1 by 4 pi epsilon naught Q1 Q2 by R. But here one important understanding, no, potential energy is also scalar quantity. Therefore, if this is negative, so keep it negative, no. If both of negatives are there, negative it will be there. So if both are positive is there, positive and positive. One is positive and negative means one is negative and positive. Therefore, which is the polarity is there, that directly only you have to keep it onto this one. You understand? No? So now here one conclusion you can get, one simple point you can understand here now. So he is therefore, if it is positive charges are there, potential energy will be more. If it is both negative charges are there, potential energy will be also more. Why? Because negative of negative, therefore it will be positive onto this, right? So here, if one is negative, one is positive means potential energy will be negative onto this. Clear? So in this way, you should be very clear onto this one, no? So we'll do some questions onto this related to this one, no? So that you can understand very clearly. We'll see some questions related to this one, no? Let us see. Here, there is a point charge is there, no, 20 microcoulomb is brought from infinity to certain point in the electric field, right? So there is some electric field is there, so therefore 20 microcoulomb is there, no, so which is at infinity, therefore this is brought it at this point, no, therefore point A, right? So therefore how much amount of work is done now? Therefore minus 40 microjoules of work is done against the field. Find the potential at that point. What is the potential here now? So work done, it will be given as nothing but a Q into, so V or V is equals to, therefore W by Q. What is W now? Minus 40 microjoules by 20 microcoulomb. Therefore how much now? So therefore minus 2 volts. It is minus 2 volts, no? Now let us do one more question here, no? Right. So when a point charge of 20 microcoulomb is brought from infinity to a point in a electric field of minus 20 microjoules of work is done by the electric field. By the field, here work done by the external agent, no? Therefore here it is by the field, no? So then what amount of work should be done by the external agent if, okay, first of all let us calculate the potential onto this one, no? Therefore what is given now? 20 microcoulomb is there now, which is at infinity. So where potential was 0 here, no? So therefore it is brought to certain point, it is A. So therefore the field was done by work onto this one, no? Therefore work done to be like a negative onto this. So therefore here how much now? What is the work done now? Work done, it will be equal to minus 20 microjoules. Therefore work done by the electric field, so therefore it will be Q into potential difference here now. Therefore here work done by the applied forces, that repulsion, no, therefore here you can take it as like a negative onto this, negative of negative, therefore 20 microjoules, it will be equal to 20 microcoulomb into V, so therefore V is equals to 1 volt. Clear? So potential at this point, it is about 1 volt here. So now what we have to do now? Therefore here, so we have to bring 140 microcoulomb from infinity to this point here now, to this point here. So how much amount of work is done? Now work done, it will be equal to Q into V. So therefore here 40 microcoulomb into 140 microjoules plus. Right? We'll see one more question here. No? So here there is what is given this question now? A charged particle of 2 coulomb is released from a point where electric potential was 10 volts. Now find the kinetic energy of the particle when the charged particle reaches to the infinity. See here, and therefore this is your there is some point is there, no, at this point. Therefore let us see here, no. Okay. Now here there is a potential is there. Now what is the potential here? No, 10 volts. Here what is the charge here? Now charge is nothing but a 2 coulomb. So therefore here when it is goes to the infinity, therefore it is infinity, the potential was 0. So at this point what will be the kinetic energy? Here initial kinetic energy was 0. So final kinetic energy we have to find it. So what is the final kinetic energy? So therefore whatever the energy stored in this one or work done, so that it will be converted into this one. Therefore here whatever the work done, it will be equal to change in kinetic energy. So work done Q into potential difference, it will be equal to change in kinetic energy. This is your work energy theorem, right? So charge is how much now? 2 coulomb into potential difference is how much now? 10 minus 0. So therefore it is 10. It will be equal to this kinetic energy. No, initial kinetic energy is 0. Final kinetic energy is this one now. So final kinetic energy minus initial kinetic energy was 0. So final kinetic energy is how much now? Therefore 20 joules of this particle now is going to gain the kinetic energy. Clear? So don't confuse, understand, no, so that you can solve the problems, no, very easily. Now we'll go for next question. No? So there is calculate the potential due to a charge at a point P located 9 centimeter away. Therefore here, so there is one charge is there, no. So what is the charge here now? Capital Q is given, no. So therefore we want to calculate at a distance of r is equals to 9 centimeter. Here we have to calculate the potential. What is the potential formula? So therefore kq by r. K is how much now? 9 into 10 to the power of 9 into q is how much now? Q is nothing but 5 into 10 to the power of minus 7 divided by r is nothing but 9 into 10 to the power of minus 2. Right? So here 9 cancel here, no. Therefore here it is 5 into therefore 10 to the power of minus 5. So 10 to the power of 4 volts. Therefore volt potential at this point is how much now? 5 into 10 to the power of 4 volts. Clear? So this is your potential at this point, right? So also find the work done in bringing another charge from infinity to that point. Therefore now we have to, okay, this is your creating the potential now. Therefore what you have to do now? When charge you have to bring it. That is what is the charge now? Small q, 3 into 10 to the power of 8 coulomb, 3 into 10 to the power of minus 8 coulomb, which is at infinity where the potential was 0. So therefore we have to bring it to this point. So we have to bring it to this point. And also one more important point you need to remember that so whatever the work done to bring the charge from one point to another point does not depend upon the path followed, depends upon the only initial and final points now. Therefore why? Because electric field is a conservative in nature now. So we will discuss that detailedly. So right now does not depend upon the path followed, depends upon initial and final points. So what is the work done now? Work done is nothing but q into v. So potential difference now is 0. Therefore here q is how much now? 3 into 10 to the power of minus 8 into 5 into 10 to the power of 4. How much now? 15 into 10 to the power of minus 4 joules. This is your work done to bring the charge from infinity to this point. Clear? Here 2 points are covered onto this one, no? Right? Now let us go for one more question here, no? So here there are 2 points are there, no? 2 point charges situated at different points now. Therefore here 2 minus 2 plus 2. Therefore here let us take this one, no? This is your x axis, no? So here 2 points are located now. Where is the 2 points now? Therefore 2 meters. Therefore plus 2 meters. Which charge now? Therefore minus 4 microcoulomb charge is located here. Therefore minus 2. So meters. Therefore here it will be how much? No, 2 microcoulomb is located at this point, right? So find out the potential at 4 and root 5 m. No, therefore here you will, therefore 4 comma 0, that means so plus 4 it is there, no, therefore plus 4 means here is asking, no, it is 4 meter. Here is asking the potential, first one V1. What you can write it now? Therefore from this point, what is the distance here now? This distance is nothing but a 2 meter. From this point, it is a distance is nothing but a, this is 2, this is 2, this is totally 2, totally 6 meters. Clear? Potential due to this one is how much now? It is minus is there, minus only. Clear? So now, so k into minus 4 into 10 to the power of minus 6 divided by distance is how much now? 2 meter. So due to this one is how much now? Therefore plus k into 2 into 10 to the power of minus 6 divided by 6 now. Clear? So this is 1 and 2, therefore 2 and 3. So therefore what you will get it now? Here V1 it will be equal to k taken common, k into 10 to the power of minus 6 taken common, no? So therefore it will be minus 2. So therefore plus 1 by 3. Clear? So minus 6 plus 1, therefore minus 5. Therefore minus 5 by 3 into 9 into 10 to the power of 9 into 10 to the power of minus 6. 3 ones are 3 threes are. So therefore here negative is there, no, negative potential was more. So therefore minus 15 into 10 to the power of 3 volts. This is your potential at 1. Clear? So now similarly, so we can calculate one more thing, no. So here potential at root 5, therefore here somewhere this is your V2. Therefore what is this? It is y axis 0 comma root 5, that means this distance is how much, no? Root 5. So root 5 means what you get it now? Root 5. Therefore what is the distance now? This is 2 meter, therefore here is distance now, this is 2, this is root 5, therefore right, this is root 5, root of, therefore 4 plus, therefore 5, therefore this distance is 3. So this distance is also 3 only, it will be there, 3 meters. Therefore here what will be the potential at this point, no? Therefore k into, therefore 2 microcoulomb, 2 into 10 to the power of minus 6 divided by 3. So plus k into, so minus 4 into 10 to the power of minus 6 divided by 3. How much it will be? 4 minus 2 minus 2. Therefore minus 2 by 3, k value into 4 into 9 into 10 to the power of 9 into 10 to the power of minus 6. 3 3 is a, so minus 6 into 10 to the power of 3 volts. So therefore the potential at this point, no, therefore minus 6 into 10 to the power of 3 volts. Clear? So just understand the question so that you can solve the problems, no, very very easily, right? So that's why right now, okay, potential at the center now. We want to calculate potential due to this arrangement, no, at the center. See 1 or 2 questions, no, I will do it, no, then remaining other questions, no, you can try. Clear? So here this is one equilateral triangle, no. Okay, we will do this one, no. Potential at the center is asking, center. So this is one charge, so it is an equilateral triangle, no. Therefore here it is, this is A, this is A, this is A. So we want to calculate the potential at the center, no. Center means what you should know it now, this distance you should know it. This distance means this distance also should know this distance. This distance is what let us calculate it, no. This angle is 60 degree, this angle is 30, no. So here it will be, this is your A by 2, this is your x distance. What you can write it now? So cos 30 is equal to adjacent side y, therefore A by 2 by x. So cos 30 is how much now? Root 3 by 2. So A by 2x get cancelled out, no. So x is equals to A by root 3. So x is equals to A by root 3. Therefore potential at the center it will be equal to 3 into, so due to this one same charge, same charge, same charge. So k q by, therefore A by root 3. What you will get it now? Here it is A into root 3. So what you will get it now? 3 root 3 q by 4 pi epsilon naught into A. So this is your potential at the center due to this charges now. So here therefore we can see one more this question. No? Let us see here. No? Therefore this is your okay, the square. Let us see here. No? So here this is one square is there. No? Right, this is one square. All charges are same. Same charges are kept here. No? So what is the distance here? No, center. No. Therefore distance is nothing but this is root 2 into A. Therefore this distance, this is R. So R by root 2. Therefore potential at the center, it will be equal to how much now? Same charges, no, same distance onto this one. No. So therefore 4 into K. K is how much now? So K into Q by therefore R by root 2. So therefore 4 root 2 into Q by 4 pi epsilon naught into R. This 4 cancel, no? Root 2 into Q by pi epsilon naught into R. So in this way. So similarly one more question, no? We can do it, no? Right here this also one square is there, no? So here therefore what happened now? Here, okay. Now there are charges are there, no? Here it is minus q, here is also minus q, here it is plus q, here is also plus q. Therefore what happened now? So we want to calculate the potential at the center of this one, no? See, so potential at the center means, so this is your positive charge, same distance, negative charge, same distance, negative charge, same distance, positive charge, same distance. So due to these two will get nullified, no? Potential at the center, it will be the 0 here. You understand, no? Still you can calculate different other combinations, no? And also you can try these questions, no? Therefore you can try this. So try to calculate what will be the electric field at every center of this one. I already discussed in our electric field video. Please go through it, no? Right? But here also you will understand that where the potential was 0, their electric field will not be 0. Okay? Will not be, may or may not be 0, right? So here, therefore where potential was 0, so therefore electric field also will be the different scenario, right? So you need to check it, right? So like this you can solve the problems, no? So in different combinations onto this. Clear? So very easy. Right, students, we will do one more question here, no? So here what is given this question, no? Find the potential energy of the system. First of all you have to calculate the potential energy of the system. There is no other electric field is there. What is the potential energy formula? K Q1 Q2 by R. K is how much now? 9 into 10 the power of 9. Q1 is how much now? 3 coulomb into 2 coulomb divided by 4. So how much it will be now? This is 2. So here 9 3 is 27. 27 divided by 2 into 10 the power of 9. How much it will be? So 13.15. Therefore 13.5 into 10 the power of 9 joules. This much amount of energy was associated with this one, right? So here also find work done in decreasing the distance by 1 meter. So therefore now the distance is decreased by 1 meter means what will happen now? So here what happened now? This is your 3 coulomb is there, and here it will be the 2 coulomb is there. Therefore now it will become like a 3 meters now. Decreased by 1 meter. Not decreased to 1 meter. Decreased to 2 means the distance between this one becomes like a 2 and that is 1 meter. Now decreased by means, so 4 meter was there, now 1 meter we have to decrease it now. So now how much amount of potential energy is there now? So we can calculate the potential energy here now. Therefore here, so same formula we can use it now. What is this here now? 9 into 10 the power of 9 into 3 meter into, sorry, here now 3 coulomb and 2 coulomb divided by 3 meter. How much it will be now? Therefore 18 into 10 the power of 9 joules. Clear? So this is your final and this is your initial. So whatever the work done, it will be equal to the change in potential energy. So therefore it will be U final minus u initial, how much it will be now? 18 minus 13.5, so into 10 to the power of 9. How much it will be now? This is so here 4.5 into 10 to the power of 9 joules, right? So 4.5 into 10 to the power of 9 joules of work is done to decrease this, decrease the distance by the 1 meter. Clear? Right? In this way you can calculate it now. Now let us see one more question here now. Right. So given this charge system now, find the potential energy of this system. What is the potential energy now? Same formula again. So k q1 q2 9 into 10 to the power of 9 into 4 into 10 to the power of minus 6 into 3 into 10 to the power of minus 6. This is minus. So divided by distance is nothing but 18 into 10 to the power of minus 2. So 9 ones are 9 twos are, therefore this is 2. So how much now? Minus 6 into, so therefore 10 to the power of 9, 10, 11 into 10 to the power of minus 12. How much it will be? So minus 1 now, minus 0.6 joules. So this much amount of potential energy so was present, right, in this system now. So work done in carrying a charge, work done in carrying a charge to infinity. That means what I should do now? So I should take this charges, no, therefore where no, I should take this to infinity, and also I should take this to infinity. Where potential was 0, therefore potential energy will be also 0 onto this one. Therefore here whatever the work done now, so work done it will be equal to change in potential energy u final minus u initial, no. So u final was 0, initial is how much now? Minus of minus 0.6, no, therefore plus 0.6 joules, no. This much amount of work we have to do it, so to take these charges to infinity. Clear? So now let us go for one more question here, no. Clear? So here, so this is one arrangement is there. Find the total potential energy of this system is 0. So calculate the ratio of q and q, small q and capital Q. So what is the potential energy here now? Potential energy associated with this one now. Here there is a 2 combinations. Are there? How many combinations? In between this one now, 1 combination, in between this one 1 combination, and this totally is also 1 combination. Totally 3 combinations are possible onto this. So what is the here potential energy here now? And due to this one, no, due to this. Clear? So how to calculate it now? Therefore here it is k into q into minus q divided by r here now. Between these two, how much it will be now? Therefore this also minus k into capital Q into small q by r. Between these two is how much now? Plus k q square by 2r distance. Clear? Therefore here this total potential energy of the system is 0, that means it will be equal to 0. That's all, simple thing, no. So this minus 1 it is taken, no, kq. So here k q square by 2r, it will be equal to 2kq into q by r. This one r get cancelled, k get cancelled, 1k 1q get cancelled. So q is equals to 4 capital Q. So how much it will be now? Q by capital Q is nothing but a 4. So it will be equal to 4, it will be our answer. Clear? Okay. So now one more question, no. So we'll discuss here, consider this system, no. So we want to calculate potential energy of any one of the charge. Any one of the charge means what? Suppose one charge I am taking, no. This is one charge, no. So what will be the potential energy associated with the charge? Therefore here whatever the work done to bring this charge, no, from infinity to this point, no. So that much amount of potential energy, potential energy is there now. Therefore work done from to infinity to bring this point, no. Therefore so to point A, therefore suppose it is P, it is nothing but how much now? Q into potential due to at this point, because of due to this 1 and 2, this is creating one potential, no. Therefore V1. So potential it is created due to this one, no, V1 plus Q into therefore V2. So what is this one now? Potential due to this Q. So this V1 what it is doing now, therefore what is the potential? KQ by, therefore it is A. So plus Q into KQ by, this potential is created now, this is A. How much now? 2KQ square by A. So this much amount of work is done, this much amount of energy stored in this charge. So that means we have to bring from infinity to certain point here. Clear? Now what we will do now, we want to calculate. Next one is what? Potential energy of the system. What is the potential energy? So like this, not only this one, no, this also you have to bring, this also you have to bring. No. Or how many possible combinations are there? This is one, this is one, this is one. Totally 3 combinations are possible onto this one. No. What is the potential energy associated with this one? No? So here same charges, same distance, same charges, same distance, same charges, same distance. That means 3KQ square by A. So will be your potential energy of this system now. This is your second question. Clear? So work done in associating the charge, associating the system. So if you want to calculate this associating this system onto this one, no? How much amount of work is done in associating the system? So work done in associating the system, therefore work done it is nothing but a change in potential energy, therefore U final minus U initial. So associating this one, therefore work done in arranging of this one, therefore initially where we are bringing now, we are bringing from infinity. So finally where it is happening now, it is like this. So this is nothing but a final potential energy. Initial potential energy was how much now? It is infinity is 0. So therefore final potential energy is nothing but a 3KQ square by A minus 0. So therefore work done in arranging this one is nothing but a 3KQ square by A. This is your answer. Clear? So like this they will make you to confuse, no, but stick on to that concepts clearly so that you can do easily these questions. Now let us see one more concept now here. Right, let us see now. Here consider the system, no, again the same thing. Now, so potential energy of any one of the charge now. What is the potential energy of any one of the charge? This charge if you are taking now. So what you have to do now, you have to bring from infinity to this point. So work done to bring from infinity to certain point P. So this charge we are bringing, therefore here, so we are bringing no, therefore this is creating some potential here, this is also creating one potential, this is also creating one potential onto this. So therefore Q, because of due to this 1, 2, 3, so due to V1, Q into due to V2, Q into V3. Q due to V1 is how much now? Therefore KQ by, it is R plus Q into KQ by, this distance is nothing but a root 2 into R, root 2 into R plus Q into KQ by R. So what you will get it now? KQ square by R, therefore 2KQ square by R plus KQ square by root 2 into R. So what you can write it now? So KQ square by R, therefore Q square by 4 pi epsilon naught into R, you can take it common here, no? So therefore 2 plus 1 by root 2, this much amount of work is done to bring the charge, no? This much amount of energy was stored in this one, any one of the charge. Clear? Now we want to calculate. So second question, no? What is the second question? Potential energy associated with the system. How many combinations are there now? So most of the students know, they will tell that it is 4. No, not 4. No. Why? This one is there 2, 3, 4, and this 4, 5, 6. Totally 6 combinations are possible onto this one. Clear? So here in this 4 combinations are very it is same, no? This one, see this one, this one, this one, this one, same charge, same distance. So these 4 combinations are equal onto this one, no? Therefore potential energy, so 4KQ square by R, these are the, because of due to this one, no? Therefore due to this 2 combinations are easy, therefore 2KQ square by, so root 2 into R. Clear? So how much it will be now? This is now root 2, therefore KQ square by R, therefore 4 plus root 2. Clear? So now what you will get it now? 1 by 4 pi epsilon naught into, therefore Q square by R into 4 plus root 2. This is your total energy associated with the system now, right? So now work done in dissociating. Work done dissociating means what? This charge you have to take it to infinity, this charge you have to take it to infinity, this charge also you have to take it to infinity, this charge also you have to take it to infinity. So work done, how to calculate it now? Just now we discussed here, right? So work done, so work done, it is nothing but a final potential energy minus initial potential energy. Finally, what is happening now? They went for infinity. Infinity means at infinity potential energy was 0. Initial was how much now? This one now. Therefore, 4 plus root 2. Therefore, here it is 4 plus root 2 into q square by 4 pi epsilon naught into r. So, this is minus is there now. Therefore, you can take it as like a minus. This much amount of work is done to dissociate this one. Clear? Clear? So you can solve the problems like this, no? Clearly. So now you can see one more question here, no? Okay. Okay. So here potential energy of any one of the charge, again the same thing onto this one, no? Potential energy of the system onto this one, no? So same thing you can solve it, no? Here you can add one more question, what is the potential at the center of this one, no? Also you can calculate potential at the center here, no? Also you can calculate it. So whenever there is a hexagon is there, no? You need to remember here, hexagon means always remember that hexagon. So this is Q, Q, and Q, and Q, Q, and Q. Therefore, this distance is nothing but a R. What happened now? Here, this is nothing but a divided into R, potential at the center now. So, potential at the center, it will be equal to how much now? Therefore, these all are equilateral triangles, no? This distance is also R. Therefore, here it is, sides are R means this also R. Clear? Potential at the center, same charges, same distance, no? 6kq by R, that is nothing but a 6q by 4 pi epsilon naught into R. This is your potential at the center onto this. Clear? Now, potential at the center, now we got it, no? So, this is an extra question, no? Not given here, no? Right? So, here is asking potential energy of any one of the charge. Therefore, this is our question. So, this question, this charge, what you have to do now? You have to bring from infinity to this point. That means, this is creating one potential now, right? So, here like that potential energy of this arrangement, no? So, slightly lengthy concept, no? Try to do it. So, here I will do this question, no? Remaining other things, no? You can try it onto this. Clear? So, now we will see one question here, no? Therefore, potential on any one of the point charge, on point charge. So, this charge, what is the work done, no? Work done from infinity to this point, no? So, this charge, therefore, this is a potential is creating q into, so V1, this is 1, 2, 3, 4, 5. So, q into V1 plus q into V2, this charge is creating the potential V2 plus q into V3 plus q into V4 plus q into V5. So, this V1 and V5 both are same only because same charge, same distance onto this one, no? So, this V1 and V5 both are same, no? Therefore, 2q into V1 plus, so these two are also same distance onto this same charge, no? V2 and this one same, no? 2q into V2 plus q into V3. Clear? So, 2 into q into potential due to this point charge, how much now? kq by r. Clear? So, therefore, 2 into q into potential due to this one, no? This distance. What is the this distance now? This distance. What is this distance? This distance now? This is like a parallelogram, no? This is nothing but a root 3 into r. What is this distance now? This distance is nothing but a root 3 into r. Clear? Therefore, here what you will get it now? Therefore, this is 2q. V potential due to this one, how much now? kq by, therefore, root 3 into r plus. So, q into V3, therefore, this distance is how much now? This is 3. So, this distance is nothing but a same as this is r and r, that is nothing but a 2r. So, q into, therefore, kq by, therefore 2r, it will be your answer. So what you will get it now, 2kq square by r plus, so 2kq square by root 3 into r plus kq square by 2r. Clear? So how much it will be now? 2, therefore here I can rewrite it as, therefore here 2, therefore you can write 4. So 2kq square by r taken common, no, 1 plus, so 1 by root 3 plus 1 by 4. Clear? So 2 means 4 pi epsilon naught, no, therefore 2q square by 4 pi epsilon naught into r, 1 plus 1 by root 3 plus 1 by 4. So this is your potential energy associated with any one of the point charge. Now you can rearrange it now, therefore potential energy associated with the system, and you can try this question now, so that you can do it very easily, this one. Clear? Clear? So now I am not doing this right, so because you can try it now, therefore you can try potential energy associated with the system, therefore how many combinations will come now, right? So therefore you can try it now, 1, therefore here it will be the 2, okay, you can try it onto this. Clear? Right, here number of possible combinations, no, we can rewrite it as one formula. So therefore n into, sorry here, no, so n into, therefore n into n minus 1 by 2. Therefore here how many are there now? Totally 6, no, therefore here 6 into 5 divided by 2, therefore here it will be 3. So totally 15 combinations it will be possible onto this. For 4 was there, no, what is the n? N is equals to 4, what we discussed here, no, previously. So here 4 charges was there. So 4 into 3 by, therefore it is 2, therefore 2, therefore totally 6 combinations. I already told, no, 6 combinations. So here we are taking, no, like that. Here 15 combinations we will get it, no, you can try it. So if you do not get it, no, please just message it, so we can see, we can do as like a one shot, therefore I can explain this concept. Clear? So now here also, therefore is asking again the potential energy, right, again this on the same arrangement. Again we can add one more question, no, what will be the potential at the center of this one, no? Is a cube. So cube means what will be the potential now? Potential at the center of the cube, no. So here right, so the potential at the center of this, you know, therefore here it will be the cube. Clear? So it's at this point now we want to calculate the potential, right? All these q are there, q, potential at the center. So this also we can add one question in this one, no, potential at the center. Therefore, so here what will be the distance now? This distance is nothing but a diagonal length onto this, in that half of the diagonal length. What is the diagonal length of the cube now? So actually cuboid diagonal of the cuboid is nothing but a L square plus B square plus H square. For a cuboid all sides are same now, therefore 3 into root 3 into L, therefore L root 3, L into root 3. Clear? So all charge, right, here we want to calculate the potential, no, at the center. So here how many charges are there now? 1, 2, 3, 4, 5, 6, 7, 8, 8 are there now. Therefore 8kq by, therefore distance, no, distance is how much now? L into root 3 into 2 divided by 2. Therefore here this distance, no. So here 8 into 2 into q by k value we can write down 4 pi epsilon naught into L into root 3. So therefore here what you can write it now? 4 2s are, therefore 4q by, therefore root 3 into pi epsilon naught into L. So in this way we can calculate the potential at the center now. This is like slightly easy question, no. So these type of questions you can expect it now, right? Right. Therefore now we will calculate potential energy of any one of the charge. See, therefore here it is slightly lengthy concept, no, but I will do this question. So remaining other things, no, you try it, no. So here we'll see we will bring this charge now. Therefore, from where? From infinity we will bring it now. Therefore, we will keep it here. So when you are bringing from infinity to here, work done onto this. So this work done. Therefore, what are the potentials it will be created now? Suppose this is 1, 2. Therefore, here it is 3, it is 4, it is 5, 6, 7. Therefore, total 7 potentials it will be created onto this. So work done onto this one. Therefore, work done to bring from infinity to certain point now. So what you can rewrite it now here. So due to q into v1 plus q into v2 plus q into v3 plus q into v4 plus q into v5 plus q into v6 plus q into v7. So this like this. Okay. So first try to observe this one now. This is 1 and this is 6 now. Therefore, these are at same distance, it is nothing but L. Therefore, 1 and 6 both are same. This 1 and 6 both are same now. Therefore, 2q into v1. Okay. Plus. Next one is what? Here. So, here 2. Here 2. Therefore, what is the distance here now? Distance is L. Here 2, what is given now? This is the diagonal length onto this one now. This 3 also diagonal length onto this. This 5 also diagonal length onto this one now. Therefore, here 2, 3 and 5. So, both are same now. Therefore, 2, 3 and 5 same distance no. Therefore, q into 3 q into v2. Okay. So, therefore, these two are over no. Therefore, v4 is nothing but a diagonal length. V4 is slightly different here no. So, therefore, here it is okay. V7, sorry, here no, V7, 7 also it will be the same here. So, this is here same as this distance no, this distance, this distance. Therefore, QV1, QV6 and V7 both are same onto this. Therefore, here you can rewrite it as, so here this is 3, this is 3, right. So, now next one is what? So, what is present, what is pending now? Therefore, q into v4. This is your work done to bring this point. Clear? So, now we will do this one now. Right. So, first v1. Therefore, 1, 7 and the distance is L only. Therefore, 3q into kq by L no plus 3q into v2. V2 is how much now? This diagonal length is nothing but a root 2 into L. So, kq by root 2 into L plus q into v4 is nothing but a root 3 into L. So, this q into this distance is how much now? Root 3 into L now. So, kq into root 3 into L. So, what you will get it now? Therefore, 3kq square by L plus, so 3kq square by root 2 into L plus kq square by root 3 into L. So, what you will get it now? Potential energy 3kq square by L taken common now. Therefore, 1 plus 1 by root 2 plus 1 by root 3. So, this is your potential energy associated with this system now to this. Clear? Now, so if you want to calculate the combination onto this one now, combination on this, so this total combination on this one now, therefore potential energy, how many are there now totally? 1, 2, 3, 4, 5, 6, 7, 8, 8 are there. How many combinations you will get it now? N into n minus 1 by 2, therefore 8 into 7 divided by 2, therefore it is 4, 28 combinations you will get it now, 28 combinations. So, it is slightly lengthy, you try it, have a fun onto this one no. So, also dissociating the energy no? Therefore, you can try it. Okay. Let us see. Okay. Here find the value of q so that the electric potential energy of the system is 0. This q again the same question no. So, this is A, therefore, root 2 into A. Clear? So, potential energy, how many possible combinations no? Again, so here the 3 only combinations are there no. So, here what you can write it now? potential energy between these two, k into q square by a plus between these two, k into q by a plus k into this is q into q divided by root 2 into a. But what he said now? He said that potential energy was 0 here now. This is 0. Clear? So now you can simplify it now. Therefore, this I can take it toward this side. So here k q by a into q also taken common now, 1 plus 1 by root 2. Clear? K q by a, 1 plus 1 by root 2 taken here now, minus k q square by a. So this is k cancel now, a cancel, 1 q get cancel out now. So therefore q is equals to, therefore here it is root 2 plus 1, therefore it will be minus q into root 2 by root 2 plus 1 will be your q. Clear? Right. Now we will see one more question here now. Right. So now we have to calculate work done in shifting this one now. First of all, let us calculate what will be the initial energy in this one now. Initial potential energy. So how many combinations will be possible? 3 combinations will be possible now. Between these two, therefore k into q into 2 into 3 divided by 1 plus between these two, therefore k into 2 into, so therefore minus 5 divided by 2 plus between these two, k into 3 into minus 5 divided by 1. Clear? So how much it will be? This will get cancelled out, no? So 6k minus 5k minus 15k. So therefore 6k minus 20k. So therefore minus 14k. K value is nothing but 1 by 4 pi epsilon naught. Now this is your initial potential energy. Now what happened now? We have to shift it to equidistance. Equidistance means what you have to do? Equidistant from the both of the remaining charges. So that means here this is your 2q, I mean 2c, and this is your 3c. So this is your 1 meter distance. No. So here we have to keep it now. Therefore minus 5c. So here you have to keep it. Therefore 1 meter distance. Therefore 1 meter distance. Equidistance. Like equilateral triangle onto this one. No? So what will be your final potential energy? Final potential energy is how much now? Therefore k into, therefore here it will be 2 into minus 5 divided by 1 plus k into, so 2 into 3 divided by 1 plus k into, so therefore 3 into minus 5 by 1 now. Clear? Therefore minus 10k, so plus 6k minus 15k, it will be equal to, so minus 25k plus 6k. So how much it will be now? So here it will be minus 19k. Clear? Minus 19k. Therefore work done, it will be equal to change in potential energy, final minus initial now. Final is how much now? Minus 19k minus or minus plus 14k. How much it will be now? Minus 5k. That means minus 5 by 4 pi epsilon naught into 1. Therefore this many joules of work is done to shift this one. Clear? Right? Now we will go for one more question now. Now again the same thing, no? I told already, therefore work done does not depend upon the path followed, no, depends upon the initial and final points. The same way here work done in transferring the plus q in the semicircular path to the distances now. Semicircular path means what? This distance is L, means this distance is also L. Therefore this distance is also, it will be L only. Clear? Now initially where are there? No, initially like this is there. Therefore finally it will be like this. Therefore initial potential energy. What is initial potential energy between these two? Therefore k into q divided by L. So between these two, therefore here it will be plus k into minus q into q by L. So between these two, therefore k into q into minus q by 2L. So this will get cancelled out onto this one, no? Minus here kq square by 2L. This is your initial potential energy. Clear? So final potential energy is how much now? Finally what happened now? This it will be your plus q, and this it will be your minus q, and this it will be your capital Q. So this distance is 2L, it is L. Now what is the final potential energy? Final now, therefore final now. So again between these two, so K into Q into minus Q by 2L between these two, so plus K into Q by 3L between these two, K into minus Q into Q by L. How much it will be now? Minus KQ square by 2L plus K into Q into by 3L minus K into Q by it is L. This it will be your final potential energy. Clear? Now we have to calculate work done. Already we know that work done is nothing but a final potential energy minus initial potential energy. So final one of this one now. Therefore minus of minus plus. So therefore minus kq square by 2L plus 3q into q, sorry not 3q, it is therefore here it will be kq into q by it is 3L minus kq into q by L. So minus of minus plus, it is kq square by 2L. This is plus and minus get cancelled out now. So here kq by 3L minus kq by L now. So kq into q by L taken common minus 2 by 3. Clear? So therefore work done it will be equal to how much no? Work done, final work done no? Work done it will be equal to, so minus 2 by 3 into, so therefore q into q by 4 pi epsilon naught into L. So this is 2, so minus q into q by 6 pi epsilon naught into L. This much amount of work is done in shifting this charge in the semicircular path onto this. Clear? Now let us do one more question here now. Here. Now let us see here now. Therefore here a charge q and m is released. Therefore what is this one now? This is charge small q, it is capital Q, right? So this is released from rest. From rest now it is released. So find the speed of the particle when the separation become 4R. So therefore initially what is the energy here now? Initial energy in between these one now. Therefore K capital Q into small q by, therefore it is R. This is your initial. Then what happened now finally? So this is q was there now. This q is become now. Therefore distance it will become like a 4R. Final potential energy is how much now? K capital Q small q by, therefore 4R. So now when the separation distance between them is increased, so potential energy was decreased. Potential energy was decreased. What happened to that potential energy? It is converted into like a kinetic energy now. Initial kinetic energy was 0. Why? So because it is at rest now. Final kinetic energy. So whatever the decrease in potential energy, so that much amount of gain in kinetic energy now. Clear? So therefore kinetic energy final it will be equal to gain in kinetic energy is equals to loss in potential energy. So loss of potential energy is how much now? U, therefore delta U. Therefore here final kinetic energy is asking speed. Speed means half mv square is equals to, so this is how much now? kq into q by r minus kq into q by 4r. So how much it will be now? Half mv square is equals to k capital Q small q by r 1 minus 1 by 4. So therefore here half mv square is equals to kq into q by r into 3 by 4. Clear? So this is 2. So therefore here no velocity. So v square is equals to k. K means here q into q, therefore 3 by Therefore here r, no, therefore 4 pi epsilon naught into r into m. So this is square is there, no, so this we can rewrite it as like a root. So this it will be your velocity after this charge, no, when it up to the distance is 4r. Clear? Now, so here therefore they are very large distance, no, very large distance, no. So therefore minimum distance, that means these are fixed onto, this is fixed, this is thrown onto this one with a charge capital Q and Q, right. So here capital Q and capital Q, correct. So therefore what will be the minimum separation? See, this is fixed, no. So initially very large distance means potential energy was 0, it is having only kinetic energy. Now what happened, now this it comes to closer onto this. So initially what is the energy, now total energy initial here, no, we can use law of conservation of energy. Initially there is no potential energy because the large distance is there, no, so potential energy will be 0, it will be having only one kinetic energy, half m v naught square. Finally what will happen now? So finally this already fixed, no, this is q was there, so this it will become like a q. So this, as it is going near to this one, no, speed of this one is getting decreased, so this it will be your least distance onto this. Clear? So whatever the kinetic energy is getting decreased, so finally the velocity will becomes to the 0. So at that point they are making like a very closest distance. At this point what will happen now? Potential energy is stored, no, k q square by therefore r, right. So whatever there is a loss in kinetic energy, it will be gain in potential energy, half m therefore v naught square. So it is q square by 4 pi epsilon naught into r. So this is 1, this is 2, therefore here r, no, so is equals to, so q square by 2 pi epsilon naught into m into v naught square. This is your closest distance onto this. Clear? And closest distance is inversely proportional to the mass of this one. So this is one of your NEET question, no, which is asked, no, closest distant approach, no, so it is inversely proportional to the mass. Clear? Right. Now we will go for next question on to this one, no? Right. Suppose here two identical charge particles are released, right, from the initial separation, no. Find the velocity of the charge when the separation becomes 2r and infinity. So just now where we discussed, no, it is exactly the same way. So here the charges are two identical charges, no, initially this much is there, when the distance become it is 2r. Just now we discussed, like that only you can try. Infinity means what will happen, no, potential energy will becomes to the 0, right. So therefore you can try this question, no, try this type of questions. So if you do not get it, no, we can use it onto this, right, we can solve it, right. So it's very easy, just now we discussed, use the initial potential energy, no, then afterwards finally final potential energy, loss in potential energy will be equal to gain in kinetic energy. Clear? Right students, see here, this one is one of very important question, no, so which is there in your CBSE textbook example question here, no. Here you need to have one learning onto this one, no. This is here two parts of the question, no. There is a 7 microcoulomb charge is there which is located at this point, minus 2 microcoulomb located at this point. There is no other external field onto this. We have to calculate the potential energy. Very simple question here, no. This is direct question, no. What is the potential energy? So where it is located? Therefore here it will be potential energy of the system, no. Therefore k into, so distance between them. So what is here now? See where it is located now? They are located at one is 9 and another one is minus 9. Clear? So therefore what will be the potential energy? Therefore here k into 7 into 10 to the power. Okay, we will write down directly onto this one. No? See here, 9 into 10 to the power of 9 into 7 into 10 to the power of minus 6 into 2 into 10 to the power of minus 6. This is minus. So why minus, no? Therefore distance between them is how much now? 18 centimeter, 10 to the power of minus 2. Clear? Distance between them is 18 centimeter. So how much it will be now? This is 9, 9 2s are, therefore 2 to cancel here, no? So minus 7 into 10 to the power of 9, 10, 11, 10 to the power of 11 minus 12. Clear? So therefore minus 0.7 joules. this much amount of energy was associated when there is no other external field now. Right. So, this is easy, just now we discussed, no. But here if an external field is exist, there is a field is there. Here what is given now? There is a certain field is there now. Here some region is there. How this region is there now? Therefore, E is equals to 9 into 10 to the power of 5 into 1 by r square. 1 by r square means what will happen now? Here, therefore, in the direction of your distance onto this one, no? In the distance, no? Therefore, field is decreasing onto this. Clear? So, initially this side field was more onto this one, no? Along the x-axis. So, like this, some field is there now. So, what will be the potential energy associated with this one? So, potential energy associated with this one now. Therefore, here not only because of due to these two charges, so we have to do this some charge is there now. Therefore, what is that charge now? So, where it is located now? This charge now. This 7 microcoulomb is at minus 9, 2 microcoulomb is at 9. So, therefore, here 7 microcoulomb is there now, 7 microcoulomb, which is we have to bring from infinity to this point. Therefore, we have to do the work done due to this one now, and also this is your minus 2 microcoulomb we have to bring from infinity to this point. Therefore, work you have to do it now, and also potential energy between these two. Therefore, potential energy between these two now. Therefore, so work done against of this one now. Therefore, this is W3. So, here potential energy it will be equal to, what is the potential energy here now? Potential energy U is equals to, therefore, here work done onto this one. Therefore, Q into due to 1 plus Q into V2 plus therefore, here now therefore, between this potential energy between these two. So, we want to calculate electric field, no, right. So, here this electric field is given, no. Electric field, what is the electric field now? 9 into 10 to the power of 5 divided by r square. This is at distance. So, what is the electric field and potential relation now? V is equals to, so E into D at the position onto this, or V is equals to at that position vector. So, here we can rewrite it as charge into potential due to this one now, potential at this point. We want to calculate V1 is the potential at this point. So, here V2 is the potential we want to calculate. Potential at this V1, how to calculate now? Therefore, electric field into this position onto this one now. Therefore, it is R1 plus Q2, therefore, Q2. So, therefore, here it is Q2 into electric field into R2 plus U. Right. So, V is equals to ED we can rewrite now. So, just we will substitute all these values now. 7 microcoulomb, 7 into 10 to the power of minus 6 into E. E is how much now? Therefore, 9 into 10 to the power of 5 divided by, so this distance how much now? Position is how much now? 9 centimeter, 9 into 10 to the power of minus 2. So, into 9 into 10 to the power of minus 2 whole square, no, into R is nothing but 9 into 10 to the power of minus 2 plus. So, Q2 is how much now? Minus 2 microcoulomb 10 to the power of minus 6 into, therefore, here 9 into 10 to the power of 5 divided by 9 into 10 to the power of minus 2 into 9 into 10 to the power of minus 2 into 9 into 10 to the power of minus 2 minus potential energy of this one is how much now? Minus 0.7. This whole will get cancelled out onto this. So, this 9 get cancelled out onto this. So, this is 7 taken here, no, this is here 7. 5 plus 2 7 minus 6 means it is 1, therefore 70, right. So, this whole 1 get cancelled out onto this one, no? This also 9 get cancelled out minus, so therefore, here it will be this is 7, therefore, it will be the 20 minus 0.7. 70 minus 20 is nothing but a 50, 50 minus 0.7, therefore 49.3 joules. This much amount of work we have to do it now. So, here the question is what? Here there is a electric field is there, external electric field is there, how to solve this type of problem. So, in the electric field, therefore, how much amount of work done, and work done due to that field, no, and also work done because of due to these two charges. So, in previous questions whatever we discussed, no, we did not consider any field onto this, right. Here we considered the field onto this, right. So, that is why you be careful onto this one, no. If the field is given, if the field is not given, no. Therefore, you will get clarity onto this one, no. Just observe this. So, therefore, you can able to solve the problems easily. Clear? So now you can see now, right? Okay, thank you. Actually this video is becoming very lengthy onto this, therefore still potential due to line charge, potential due to the sheet, and potential due to the sphere and concentric spheres, right? So this all will do as like a part 2. I thought of completing, and also equipotential surfaces is there, so that all will conclude in the part 2. Here only potential and potential energy we discuss, go through it. This is like a part 1, and part 2 will make a video based on equipotential surfaces and potential due to line charge, potential due to the sheet, and potential due to the spheres, and all this. Clear? Right? So thank you for watching. So please subscribe to my channel. So listen the classes, we see the videos, take a notes, see all the different model questions, which I already discussed. So take a notes, so that you need not to go anywhere coaching onto this, like a tuitions and all this, so that you can learn complete physics for your NEET and IIT JEE level. So right, all competitive examinations, board examinations, even teacher trainings and all this, it will be helpful. Okay, thank you. Please subscribe and share those who require the physics classes. Thank you.